The recent surge in artificial intelligence development has yielded remarkable advancements, particularly in the domain of image and video synthesis. Nvidia, a prominent chip designer, has unveiled groundbreaking research showcasing the integration of AI-generated visuals with conventional video game engines. This innovative approach presents a hybrid graphics system with potential applications in video games, filmmaking, and virtual reality. Today, we are going to discuss how AI is used in virtual reconstruction of the world. According to Brian Cantazzaro, Nvidia's vice president of applied deep learning, this method represents a novel way to render video content through deep learning techniques. While not achieving photorealism and displaying some characteristics of visual artifacts common in AI-generated imagery, Nvidia's results are a significant step forward. The research builds upon existing methodologies, notably leveraging the principles of a widely recognized open-source framework called Pix2Pix. Utilizing generative adversarial networks, or GANs for short, a prevalent neural network architecture in AI image generation, Nvidia's work contributes to the ongoing evolution of this field, exemplified by recent milestones such as the sale of an AI-generated portrait by Christie's. Nvidia has spearheaded numerous advancements, including what it claims to be the inaugural video game demonstration featuring AI-generated graphics. This demo showcases a basic driving simulator set within AI-created city blocks, where players are confined to their vehicles without interaction with the environment. Notably, this demo operates on a single GPU, a significant feat considering the cutting-edge nature of the technology. However, it is worth mentioning that the GPU utilized is Nvidia's top-tier $3,000 Titan V, renowned as the most powerful PC GPU available, primarily employed for advanced simulation processing rather than gaming. Nvidia's system employs a series of steps in generating graphics. Initially, researchers gathered training data, sourced from open-access datasets commonly used in autonomous driving research. Subsequently, this data undergoes segmentation, categorizing each frame into distinct elements such as sky, vehicles, trees, roads, and buildings. A generative adversarial network is then trained on this segmented data to produce novel renditions of these objects. Subsequently, engineers established the fundamental framework of the virtual environment utilizing a conventional game engine. Specifically, they employed Unreal Engine 4, a widely utilized engine recognized for powering prominent titles like Fortnite, PUBG, and Gears of War 4. Within this framework, deep learning algorithms take charge of generating real-time graphics for various categories of items, seamlessly integrating them into the game engine's models. Brian Cantazzaro elaborates that while the world structure follows a traditional creation process, the AI exclusively focuses on graphic generation. He emphasized that the presented demo is rudimentary in nature and was assembled by a solitary engineer. It serves as a proof of concept rather than a fully fledged game experience. Nvidia's engineers encountered several challenges in developing the system, with objects' permanence posing the most significant hurdle. Maintaining consistency in object appearance across frames, especially when generating graphics at a rapid rate like 25 frames per second, proved problematic initially. Brian Cantazzaro notes that early iterations suffer from jarring fluctuations in colors and textures from frame to frame. The solution involved equipping the systems with short-term memory, enabling it to compare each new frame with the previous one. By predicting elements such as motion within images, the system generates new frames that align with the current screen content. However, this computational process incurs significant overhead, limiting the game's frame rate to 25 frames per second. Cantazzaro underscores that the technology is in its nascent stages, suggesting that it may take decades before AI-generated graphics become commonplace in consumer titles. He draws parallels to the development trajectory of ray tracing, a technique for rendering realistic reflections and shadows in virtual environments, which took a considerable amount of time to transition into mainstream gaming. While the primary focus is on gaming, the technology holds promise for other fields such as robotics and autonomous vehicles, where it could facilitate the creation of realistic training environments. Additionally, it can see earlier adoption in consumer products, albeit in a more restricted capacity. One potential application involves integrating AI-generated graphics into a hybrid graphics system, where traditional rendering methods are predominantly used alongside AI-generated likeness of people or objects. This approach can enable consumers to capture footage using smartphones, which could then be uploaded to the cloud for algorithms to learn and incorporate into games. This capability could streamline the creation of personalized avatars that closely resemble players. Despite its potential benefits, experts express concerns about the misuse of AI-generated deepfakes for disinformation purposes. The advancement of such a technology raises significant concerns, particularly regarding the proliferation of AI-generated deepfakes for disinformation and propaganda purposes. However, Nvidia contends that this issue isn't novel. Brian Kentazaro acknowledges the potential for misuse, but asserts that any rendering technology can be exploited in this manner. Nvidia claims to collaborate with partners to explore methods for detecting AI-generated fakes, yet emphasizing that combating misinformation ultimately requires addressing trust-related challenges through a multifaceted approach, not solely relying on technological solutions. 3D reconstruction involves generating a three-dimensional representation of an object or a scene using a set of 2D images or videos. It's a multifaceted process that entails extracting geometric details like depth, shape, and texture from input data to produce a digital model that faithfully mirrors the real-world subject. Sitting at the intersection of computer vision, computer graphics, and image processing, 3D reconstruction employs various techniques, such as feature detection and matching, camera calibration, stereo vision, and structure from motion. The integration of AI and ML algorithms enhances and automates these methods, resulting in quicker and more precise reconstructions. In the medical field, 3D reconstructions is instrumental in generating detailed models of anatomical structures from medical scans, aiding in surgical planning, diagnosis, and treatment assessment. It is also pivotal in augmented reality and virtual reality applications, enriching experiences by seamlessly blending in virtual objects with the real world through real-time environment reconstruction. Robots and autonomous systems leverage 3D reconstruction to perceive and comprehend their surroundings, facilitating navigation, object manipulation, and environmental interaction. Furthermore, it finds utility in the preservation and restoration of cultural artifacts and historical sites, enabling researchers to study and document these treasures without jeopardizing their integrity. As technology progresses, the scope of applications for 3D reconstruction continue to broaden, reflecting its versatility and significance across various domains. The realm of 3D reconstruction presents dynamic career prospects for individuals in roles such as data scientists, computer vision engineers, and researchers. With the escalating demand for 3D models in virtual environments, professionals adept in 3D reconstruction techniques are in high demand. The realm of 3D reconstruction is an intriguing domain where AI/ML, computer vision and image processing, converge to convert 2D data into intricate 3D models. Its diverse applications span numerous industries, with its importance steadily expanding. As technological advancements and AI methodologies progress, the precision and effectiveness of 3D reconstruction are poised to enhance, opening up fresh avenues and prospects. For those intrigued by the potential of AR and VR, devoted to safeguarding cultural heritage, or eager to contribute to pioneering research, a profession in 3D reconstruction presents a plethora of opportunities. Embracing the challenge of translating the world into 3 dimensions unveils the potential to visualize the imperceptible, offering a gateway to unleash the power of perception and innovation. That's all about today's video. If you like this video, then don't forget to like and subscribe to our channel. Also, press the bell icon to get notified of our upcoming videos. Let us know your opinion in the comment section below.